Okay, you're most welcome once again to my YouTube channel. It is still your tutor Peter Ikaja, and today I welcome you with type 3 of partial fractions, where we have a denominator with a repeated factor. Now, when we talk about a repeated factor in this case, it is a factor that repeats itself at least more than one time. I am going to specifically begin with this example that you can see here. It says express 1 over x plus 2 into x minus 1 squared into partial fractions, and hence find the integral of the same function. When you look at x minus 1 squared, this is a repeated factor. Why? Because the factor has a power 2 here, meaning it repeats itself twice. So you can also have power 3, power 4, and many others. And that is what I'm going to be showing you how to deal with them. Now, basically, there is nothing so strict about this. Nothing so strict about it at all. We just need to begin by saying, we let 1 over x plus 2 into brackets x minus 1 squared to be equals to 1 over, I have the first factor, so I will say, actually I will say a out of x plus 2. I've taken a choice of using a, just like we've been doing in the previous tutorials, plus. Now, for the repeated factor, you must be so careful. It has power 2, but we begin with power 1. So I will say b divided by x minus 1, but power 1. And then from there, I say c divided by x minus 1, but squared. That means if we had a power 3 here, we would proceed up to d divided by x minus 1 cubed. For this case, we are stopping at the square, so that is where we can stop. The next step is realizing that on the left-hand side, we have a denominator x plus 2 into brackets x minus 1 squared. Should you get the LCM of the right-hand side, it is still the same as the denominator of the left-hand side, and therefore they will be cancelling out. That means we shall have 1 on the left equals to a into, for you to get what you're going to write here, you simply get the LCM, which is x plus 2 into x minus 1 squared divided by x plus 2. So you end up with x minus 1, but squared, plus, come to b, you get the whole LCM divided by x minus 1. You will end up with x plus 2 into brackets x minus 1, plus c, get the LCM divided by x minus 1 squared, you will end up with x plus 2. And then from here, we can begin with the cover-up method, and later either we substitute a value of our choice, or we can equate coefficients as we did in type 2. So I can begin by putting x equals to 1. How did I obtain it? I equated x minus 1 to 0 to get the value of x. So when I put 1 on the left-hand side and right-hand side, definitely on the left we shall have 1 is equals to, on the right-hand side, the whole of this term becomes 0. The whole of this term becomes 0 because we have x minus 1 here. So we only remain with c into brackets 1 plus 2, which is 3. So if you have 3c equals to 1, it definitely tells you that c becomes a third. So we do the same by equating the next factor. I can equate x plus 2 to 0. That means we shall have x equals negative 2 to look for another constant. So we can continue in that way. So when you put x equals to negative 2, definitely it means on the left-hand side, we shall still have a 1 is equals to, now the right-hand side, the second term, the whole of this becomes 0 because of x plus 2 appearing here. The whole of this becomes 0 because of x plus 2 appearing there. That means we remain with a into brackets, I say in the place of x, I'm substituting -2. So -2 minus 1, that will be -3, but squared. -3 squared is definitely 9. That means we shall have 9a equaling to 1. And that means the value of a becomes 1/9. Finally, we now look at the expression. You will realize there is no other factor we can equate to 0 to get a value to substitute. So we are going to make a decision to either substitute any value of our choice, except the ones we have already used, or we can equate coefficients. Preferably, I will equate coefficients. So I can say equating coefficients. Equating coefficients of, preferably I will take x squared. What will happen on the left-hand side? We don't have x squared. That means the coefficient is 0. On the right-hand side, we can look at the first term. When you expand it, the coefficient of x squared will be a. When you look at the second term, when you expand it, the coefficient of x squared will be b. And the third term will not have x squared. So we can stop here. And that means 0 is equals to, we know the value of a as 1/9 plus b. And therefore, tells us that the value of b becomes -1/9. Now that we have got the values of a, b, and c, we simply go back and substitute at the very first step where we started from, this very step here. We can therefore say that 1 out of x plus 2 into brackets x minus 1 all squared is going to be equals to 1/9 into x plus 2 minus 1/9, because we have x minus 1, and then finally 1/3 into brackets x minus 1 but squared. And then definitely the remaining task for us here is to integrate, which we can comfortably do. So you can now say the hence part. The integral of 1 out of x plus 2 into brackets x minus 1 squared with respect to x is as good as integrating each of these fractions independently. So I will have that, the first term, 1/9 into x plus 2 with respect to x minus integral of 1/9 into brackets x minus 1 with respect to x plus integral of 1 out of 3 into brackets x minus 1 squared with respect to x. Be sure that from this step now, you are supposed to use the knowledge of the previous videos to tell us the integrals of each of these. And if you've gone through those previous videos carefully, you will realize that now our integral of 1 out of x plus 2 into brackets x minus 1 squared dx is equals to. Now we begin by integrating 1/9 into brackets x plus 2. So that gives us 1/9 natural logarithm of x plus 2. And then when you integrate 1/9 into brackets x minus 1, shall of course get 1/9, but remember we have a negative here before it, then natural logarithm of x minus 1. The negative was on our constant, that's why we have it there. And then definitely we shall now also believe that when you integrate 1/3 into brackets x minus 1 squared, you will come up with -1 out of 3 into brackets x minus 1, and then plus our constant of integration. So that becomes our integral. Now let's look at example number 2. So our example number 2. So our example number 2 says we express 2x squared minus 5x plus 7 divided by x plus 2 into x minus 1 squared into partial fractions. Hence find integral of that. Definitely we shall use the same procedure. So we shall begin by letting 2x squared minus 5x plus 7 divided by x plus 2 into brackets x minus 1 squared to be equal to a out of x plus 2 plus, this is a repeated factor, so we shall first say b divided by x minus 1. We said we start with power 1. So power 1, of course, is as good as having x minus 1. And then plus c divided by x minus 1 but squared. From this, again, we realize the LCM of the right-hand side is the same as the denominator of the left-hand side. And therefore, mathematically, they cancel out, leaving us with 2x squared minus 5x plus 7 is equals to a into brackets. Now we get the LCM divided by x plus 2, which gives us x minus 1 but squared, plus b, we again get the LCM divided by x minus 1, which gives us x plus 2 into brackets x minus 1. And then plus c, get the LCM divided by x minus 1 squared, you will end up with x plus 2. Then from here, we can look out for the values of a, b, and c. For example, when we begin by equating x minus 1 to 0, we shall realize that the value of x in this case becomes 1. So if you put x equals to 1 on the left-hand side and right-hand side, we expect on the left-hand side to come up with a 4, because that will be 2 minus 5 plus 7. 2 plus 7 is 9, minus 5, that is 4. The right-hand side, when you look at it carefully, the first term becomes 0, the second term becomes 0, and then the third term gives us 3c. That means definitely that the value of c becomes 4 divided by 3. Then we continue to other constants. We can now go on and put x equals to -2. How did I get it? I equated x plus 2 as a factor to 0. And that means on the left-hand side, when you put -2, you're going to come up with 25. On the right-hand side, you're going to come up with 9a. And that means the value of a becomes 25 out of 9. Then, now you realize all the factors have been exhausted. So what you do in this case, two options. Either you take up any value of your choice with exception of x equals to 1 and x equals -2, or you can as well equate coefficients. But I would prefer to equate coefficients. So I will say equating coefficients of preferably x squared. What will happen? We shall have a 2 on the left. On the right hand side, we shall have a. In case you expand that, you will have a as the coefficient of x squared, and then plus b. But now you realize we know the value of a already. It is 25 out of 9. And then plus b now. That means the value of b, if you calculate carefully, will be 2 minus 25 out of 9, which gives us -7 out of 9. Now that we have all the values, we can do our substitution. In the very first step. So we shall conclude by saying that therefore 2x squared minus 5x plus 7 divided by x plus 2 into brackets x minus 1 squared is equal to 25 out of 9 into x plus 2 minus 7 out of 9 into brackets x minus 1, and finally 4 out of 3 into brackets xc minus 1 but squared. So from there, we are done with expressing our fraction as a partial fraction. That means we now need to integrate, and therefore we can say the integral of 2x squared minus 5x plus 7 divided by x plus 2 into brackets x minus 1 squared dx is just going to be the integral of 25 out of 9 into brackets x plus 2 dx minus integral of 7 out of 9 into x minus 1 dx plus integral of 4 out of 3 into x minus 1 squared dx. There we are. Now from there, the integrals of this, again, when you refer to our previous tutorials, you will realize that the basic technique here is just realizing that we shall have 25 out of 9 natural log of x plus 2 for the first integral. The second integral we shall have minus 7 over 9, but natural log of x minus 1, and then plus, actually it's supposed to be a minus now. When you're integrating 4 out of 3 into x minus 1 squared, you're going to let maybe any variable like u to be x minus 1 and follow the normal procedures as it was illustrated in the previous tutorials. You will end up coming up with negative 4 out of 3 into brackets x minus 1, and then plus our arbitrary constant of integration. So this brings us to the end of the second example, and clearly I can now say you are ready for a simple exercise. And it's right here. It's a very simple one. Try it out in case you get any challenges. My contact was on the very first part of this video. Get in touch and we help each other. And I also remind you to subscribe to this channel, and don't forget to turn on the notification button or bell so that you are always notified whenever I post a new video for you to continue following smoothly and easily. See you in the next tutorial. Bye-bye.